Hello, this is Miss Moore, and today during chemistry we're going to continue our discussion on heat flow and phase change. For this portion of the lecture, please make sure you have your calculators handy. Let's start with a discussion on heat effusion. So heat effusion, or delta H fuse, is the amount of heat needed to melt or freeze 1 gram of a substance. If we're talking about melting or freezing, we're talking about the two phases of matter, solid and liquid. Right? So if we were melting, we'd be going from solid to liquid, and if we were freezing, we would be going from liquid to solid. So heat effusion deals with the transfer or the change of state from solid to liquid, liquid to solid. Okay? So for heat effusion, there is an equation. It's Q equals M times delta H fusion. Q is the quantity of heat, and that will be either in calories or joules. Those would be the units. Then you have M. M is the mass of the substance, in grams, of course. And delta H fusion is the heat of fusion. It's different substances have a different heat of fusion. Okay, that's a constant per a particular substance. Next up, heat of vaporization. Heat of vaporization, or delta H vape, is the amount of heat needed to either vaporize or condense 1 gram of a substance. So if we're vaporizing or condensing, we're talking about the liquid and gas phases. So if we're vaporizing, we're going from liquid to gas. And if we're condensing, we're going from gas to a liquid. We have an equation for heat of vaporization, which is exactly the same as heat of fusion, so we have Q equals mass times delta, but this time it's vaporization instead of fusion. All right, so again, Q is the quantity of heat in calories or joules. M is the mass of the substance in grams, and delta H vaporization is the heat of vaporization, which is a constant, again, for a particular substance. Every substance has its own delta H, or heat of vaporization, just like every substance has its own specific heat of fusion. So now let's try a couple practice problems. So the first one is, how much heat is needed to vaporize 75 grams of water? So we need to know, first of all, if we're going to be using the equation for heat of fusion or heat of vaporization. But we're vaporizing, right? So we must be using the formula Q equals mass times delta H vaporization. Now we just plug this in. Q is the amount of heat. We know we have 75.0 grams, and we're going to multiply that by the constant for water for heat of vaporization, which is 2,260 joules per gram. So grams will cancel out, and when we multiply, I got 169,500 joules. We got to look at sig figs. Because this is a constant, we won't use that as for sig figs. We'll just use our given. So that's going to be 3 sig figs. When we round up, we're going to end up with 170,000, which joules, which unfortunately only gives us 2 sig figs. So let's change this to scientific notation. There you go. And that's how we solve for heat of vaporization. All right, practice problem 2. If you can, why don't you hit pause, try to do this without me, and then hit play and see how it went. All right, so this time we are looking at heat of fusion. So we'll be using the formula Q, which is the amount of heat, equals the mass times the heat of fusion. Okay, this time they give us a heat unit, so that must be our Q. So we'll have 2150 joules equals, they give us the mass, which is 56.5 grams, and what we're trying to find this time is the heat of fusion. So, to solve for x, we'll divide both sides by 56.5 grams, and that gives us 38.0530, etc. joules per gram. And now if we go back and look at sig figs, we have 3 sig figs here and 3 sig figs there, so our answer will have 3 sig figs. So as a final answer, the heat of fusion, so the delta H of fusion for sulfur is 38.1 joules per grams. All right, that's it for today. Have a good one.